Okay, so chapter 4 is about quadratic equations, and chapter 3 was about quadratic functions. Okay, so basically we're going to do very similar things, except this time we're dealing with equations. Okay, so let's get right into it. Before we get into factoring quadratic equations or finding the solutions of them, we're actually going to take a look at a very short and sweet method of graphing these equations. And when you graph an equation, graph the corresponding function to an equation, then you get to look at the x-intercepts. Okay, and the x-intercepts will actually be the roots or solutions of a quadratic equation. Okay, so for instance, if you had the quadratic equation x squared equals 0, you could actually plot the graph of f of x equals x squared. Okay, this would be the corresponding equation, and that would look like that, where you're going to have a solution or an x-intercept at 0. So 0 should satisfy this equation, which it does. Put in 0, and you get 0. Okay, we're going to take it to a more complicated example. So, there are basically 3 different possibilities that can occur when graphing quadratic equations. You can get 2 x-intercepts like this. Okay, the quadratic function could either be concave up or concave down. You can have one solution, like right here, if it's just touching, or you can have no solutions. Okay, and that would be if you rotated this graph up or down. Okay, the key though is that the x-intercepts are the zeros or the roots of the function. Okay, that's how that would be your solution for the corresponding equation. Okay, so take a look at this slide, highlight it in your notes, because these pictures, right, picture 1, actually we should match it up with the cases here. Case 1, one real root. Well, that's this right here. One real root, right? It's right there. Case 2, 2 distinct real roots. Well, that would be something like this, right? If the graph or the if the function passes the x-axis at 2 different points, and if there are no real roots, that would be this guy right here. So all we have to do is graph the corresponding equation, and you get the solutions. The problem is some of the graphing can be really tedious. It can be difficult to do, right? So I'm not going to fight this. In a real application, quite often you might have access to technology, okay? And what I'm teaching you in this chapter is that, I'm going to teach you the quadratic formula. I'm going to teach you how to factor to solve these roots as opposed to graphing. That's not just to avoid using technology. Technology is absolutely important. But the way that technology actually processes information is using the techniques I'm going to share with you. Okay, but that being said, a very fast way of getting the solution for x, okay, in any application here, would be to simply graph it using technology. Okay, so I'm going to use the online graphing calculator Desmos. You can use any graphing calculator you want, and let us do some examples. So I'll do these 3 examples right here. X squared minus 6x plus 9, 0 equals 600 minus 6x squared, and 3m squared minus m equals negative 2. Okay, to look at the first one, the corresponding equation would be f of x equals x squared minus 6x plus 9. Pretty easy to graph, but let's just go ahead and use our graphing technology. Okay, so for the first one here, you can see off to the side, we have f of x equals x squared minus 6x plus 9. Here's the graph in red, and here's our solution right there, 3 and 0. we can ignore the y coordinate and just focus on x, because the solution is in terms of x, right? F of x. We're interested in what will make this 0. So the answer is 3. Okay, and there's only one solution, so this would be a case 1 example. Okay, so for this first one over here, we would have x equals 3. That's it. Very simple. Very, very simple. Okay. For B, 0 equals 600 minus 6x squared is the same thing as saying f of x equals 600 minus 6x squared. Let's take a look at that in Desmos. When you take a look at that, I'll erase this, and you can see that this is going to be a massive equation. It's going to go all the way up to 600, but you can see where it crosses the axes. Okay, at -10 and 10. Okay, and you can check if you put a -10 or 10 in here, that will make this 0. And so those are your two solutions. That'll be a case 2 example. Okay, so you bring this up again, and the solutions to these equations would be x equals -10 or x equals 10. And for part C, 3m squared minus m equals -2. This would be the same thing as saying f of m. I'm going to move this 2 over, okay, because you want it in terms of m equal to 0. It would be 3m squared minus m plus 2, just like that. When you take a look at Desmos, you erase this, replace this one, and lo and behold, you can see that there are no solutions. It does not cross the x-axis, or sorry, in this case the m-axis, okay? Which means there is actually no real solution to this equation that would make it 0. Okay, so in this case, in this case, there are no solutions. Just like that. Very easy. Now, of course, graphing this by hand would be annoying and tedious, and if you're going to do this by hand, graphing it would not be a good choice. You've probably realized, well, why aren't you just factoring this? Well, we're going to factor it in the next sections. Okay, but this would be something very quick in different applications in different sciences, okay, economics, okay, and so on and so forth. If you wanted the solutions to any equation, okay, not just quadratic equations, but any function or any equation, you can actually just graph the corresponding function, okay, and then it's going to give you, one of these, if it's going to cross the axis that you're interested in, and that would be your solution. Okay, so this section, while it's very, very easy, is very important at the same time. Okay, so make sure you take a look at the practice problems and ask me if any questions. If not, let's go into the next section.